Hello, my name is Enric Fontdecaba and I will introduce today different advancements that we have done in EURECAT regarding plastic parts with structural requirements. First of all, short introduction of what is EURECAT. EURECAT is a technological research center. We are around 650 people working on different specialities, and our turnover is around 50 million euros, and we have more than 1,700 different customers. We work on different large R&D projects funded by the European community here near Barcelona, and we also work with small and medium companies. More than half of our clients are from these kind of companies. We are the second technological center in Spain. We are based in Catalonia, near Barcelona. We have different locations around all the Catalan country to be closer to our industry here in Catalonia, in Spain. We have different specialities from water technology to medical devices, nutrition. We also work in artificial intelligence in industrial environments, on lightweight materials, and we were discussing today about this kind of material. The first technology that I would like to introduce to you is the EBIT technology. It's a manufacturing technology that combines two different processes. In one side, we have the extrusion blow molding process, and in the other side, we have the injection process. And we have developed a tool that combines both processes. The idea is to be able to make a part that combines both the advantages of both worlds. Yeah. So today we have different parts in the automotive sector that combines this extrusion blow molded part with the injected part, and we have complex logistics around it because we have to, first of all, make the tube, the extrusion blow molded tube. Then you have to make in your plant or in another section of your plant the injection parts, the brackets or the fixings. Finally, you have to weld both together, yeah, and then you have the end product. So you have different scrap in different parts. You have stocks, intermediate stocks in different parts. But we have developed a machine that combines both technologies in the same machine, so you can make the part in one step. Okay, where we can apply this technology? Basically in tubes that needs fixing inside the automotive sector. For example, air ducts, for example, or fluid ducts. We could also use in fuel tanks, for example. That's inside the automotive industry, but also in other industries like bottling or industrial tanks could benefit from this kind of technology. How it works? It's here you have the 3D parts also explained. Yeah. Here in the upper part of the slide, you can see the conventional extrusion blow molding unit with the accumulation head and the extruder that accumulates the material that will be later on extruded and put inside the mold as a tube. And in the left part, you have the injection unit, that is a conventional unit. And here you have in the middle the press section. Depending on the size of the machine, you will have on the size of the part, on the size of the injected part versus the extruded part, you will have an extrusion blow molding machine where you adapt an injection unit, or an injection machine where you adapt an extrusion unit. In more detail, the machine works like that. First of all, there's the closing of the mold that could be inside an extrusion blow molding machine or an injection machine. With the mold closed, you have the extrusion of the tube. At the same time that you have the extrusion, you have the suction to be able to move the tube inside the part. Yeah. Afterwards, you close the tube, so you are able to increase the pressure. So this increased pressure is the one that allows you to mold the tube up to the shape of the mold. Finally, you put the injection unit on, and in the injection unit, you make the injection part. Yeah, and then you open, retire the injection unit, then open the lids that close the tube, and finally you remove the part. Yep. Okay, we have worked extensively on these parts, and we have we have worked with different materials to check the compatibility. So we have different materials here. For example, polypropylene, mix of polypropylene with polyethylene, polypropylene with tar powder, high density polyethylene, polyamide with glass fiber polyamide, or thermoplastics, different thermoplastics of elastic properties. Yeah, and we have developed the compatibility with extrusion and injection mold. Basically, all these materials are compatibility between them. For example, but you know, the polyamide is not compatibility, so it has no good addition with polypropylene. We have developed two different technologies around it. Let's see an example, and I will show you what kind of parts you can do with that. And I will show you this part physically. So here you have this tube that has different. Here you have a air outlet. Here you have a bracket for fixing. Yeah, this air outlet will be done in one phase of the process, and this part will be done in another phase of the process. Yeah, and here you have the part. You can see the real part on that. I show it in the camera with the two different brackets. Yeah. Here you can see also another part. Here the overmolded material is in another color, so it's easier for you to see the shapes. Yeah, these two outlets. Okay, we have worked extensively on how we weld the part together. So we see that we started with a welding that was a flat shape, and then we realized that it was better to use this structured surface. Yeah, and we have done these changes on design. That's the work as we do as a technological center. We develop technologies, so we have to look at the defects and devise solutions for improve these defects. You see the real machine. It's a Mateu Soler. Mateu Soler is a Catalan equipment manufacturer, and this is the extrusion block molding machine, and this is the injection unit that we work on. As I mentioned before, our work is in developing the process, so we need to, previous to make the different mold and different solutions, to make simulations. So we simulate the physical part that I showed to you was previously simulated, and we look for different solutions to improve the strength of the junction, and also to avoid the collapse of the tube. Yeah. In the first simulation we had a collapse, as you can see here, depending on the conditions of the overmolding conditions. And finally, redesigning the part using, for example, this corrugated surface with this structured surface, we can stand the estimated overmolded pressure that we have in this. You have another demonstration of the part. That's a different part that I showed you before. It's this one. Yeah. Here you have. In this one, we have two different materials because the basic structure is flexible. Yeah, you can see. I can bend the tube because it's a TPE. But we have also overmolded a rigid part for fixing it with a perfect welding. Okay, you see sections of this part, for example, like here. Yep. This is the section of a part of the perfect soldering of different materials. That's the main advantage of this technology. We have the logistic advantages, so you are able to have this very good logistics that avoids all the internal management of material, but also you have the advantage of the strength of the union. So you have better unions within the brackets and the tubes. This is another example where you can see all the different possibilities. You can put different nipples in different parts or different brackets in different parts. You can also have this kind of materials that are more or less flexible, TPEs or TPUs that can be blow molded. We make this technology evolve to a part that has a bigger injected part. The idea was to develop a structural part. Structural parts that were able to combine the air conduction with the structural rigidity of the tube with the versatility of the shapes that injection molding can provide. So the EBIT technology developed at EURECAT has three different steps. So one was the EBIT process, where the bigger part was a blow molded part with rigid materials, and that was on the initial project that we did. Later on, we evolved to flexible materials like TPEs, changing the sequence of molding and blow molding, like this one. And finally, we went for bigger structural parts, like this one that I have here. Yeah, that I will discuss later. In this case, the machine it's an injection machine, a 1,000 tons machine, where we put an extruder over it, and we work with different prototypes in polyamide and polypropylene. The idea of the demonstrator that we did was to combine the air ducts that you have in the cockpit of the car with a structure that you need to support all the cockpit details. Currently, these parts has a metal structure, and then with welding you have different plastic parts over it. The idea was to translate to a complete plastic part solution where you combine the tube that has the properties for air conduction, but also it provides the rigidity that needs the part, with the plastic part. Here you can see the plastic part that allows you to clip all the parts that need the cockpit. And we did this demonstrator part, that it's this gray part is blow molded and the red part is over molded. So we have different sections on the blow molded part, but also different kind of unions in the red part. As you can have seen before, but also we focused on avoiding the collapse of the tube, and here you can see images where you can see that the tube is not collapsed. But also that was one of the main issues on our development, and the other one was to test the rigidity of the union, and the union is perfect. So you have problems, as you can see here. you break the plastic part, the injected plastic part, before having problems in the union. So we get the expected results. We have a process that can combine extrusion blow molding with injection, providing a perfect solder between the two parts. Apart from the automotive sector, we think that this process could be also used in furniture, in logistics, but also in water tanks or in traffic signs, also in decorative elements or playgrounds, where you need the flexibility of the injection of the shape that you can have with injection parts, with the structural rigidity that you obtain with these extrusion molded tubes. So, to summarize, in EURECAT we have developed this extrusion blow molded with injection process that combines the advantages of both parts. We have the industrial setup to test it, and we have also the tools and the knowledge to use this process. The advantages of the technology are the integration and all the advantages that allows you reduce the volume of parts and to avoid this use of metal in this plastic part, so you increase the recyclability of the part. And also you have also the cost reduction due to the reduction of logistics inside the production site. And on the drawback, you have to be aware that you need a very good process control, since the coordination between the blow molding and the injection phase has to be done correctly to avoid the tube collapse. Then now I would like to change the topic and go to another structural part that combines not two different plastic processes, but two different materials. We will integrate inside the injection process continuous glass fiber or continuous carbon fiber. This is the process that we have also worked here at EURECAT. We start with an organosheet. Organosheet is a laminate of continuous glass fiber or continuous carbon fiber with thermoplastic materials like polypropylene or polyamide. These films can be thermoformed. Yeah? So in the process, this reinforcement sheet it's head up, then it's thermoformed at the same time that we do the injection. Yeah? And we have worked with reinforcements from 0.5 to 3 millimeters thicknesses in polypropylene and polyamide. And we have made overmolding of these reinforcements with up to 40% glass fiber materials. We have done this demonstrator. This demonstrator it's a structural part. You see here the part. It's a complete bumper. That's the part that goes inside the bumper of the car. Yeah. Those are images of our process here at our pilot plant. Here you have the IRO and that will heat up the organosheet. Here you see the oven working and heating the part. Later on you have the extraction of the part. You place the part on the mold, then you close the mold, and afterwards you open the mold and you have the part ready for working. This is a 1500 tons machine that we have here at EURECAT pilot plant near Barcelona. Here you can see a video of the process. That's the heating part. Now the robot takes the organo sheet and puts it inside the mold. Now we close the mold. On the mold closing, we thermoform the organo sheet. Now we inject the plastic part. And finally, we open the mold. And we have the part ready. We have also make small demonstrators of this part, so are easier to test different processes and test different materials. And we developed a small box like this one that I have here. The idea of this small box is that you could do reinforced boxes for example, in the battery packs, or for safety components inside the automotive to avoid steel reinforced boxes and to reduce weight and have good properties. We also work on reinforcing the blow molded tubes. And here you have an example of a tube where we put an external reinforcer that was in carbon fiber. Yeah. These parts could be placed in different zones of the car. For example, in the reinforcement inside the door, or here in the front and rear part after the bumper, but also you get also in the part where you sit, the sitting part. For example, this is the sitting part. Yeah. And different parts also in doors or in floors or trunk floor, for example, for reinforcing different zones, or in the frontal part of the car also. So, just to summarize the presentation that I've done, I tried to present two different processes that combines different technologies to increase the added value of plastic parts. In one of the examples, we show to you a plastic part that combines injection and blow molding. So we can have parts that avoid all the processes to integrate the plastic part inside the blow molding, and you can have or better soldered parts, or parts that has a structural rigidity provided by the tube, the blow molded tube. That was one of the parts of my talk. And the second part was the introducing of continuous glass fiber or continuous carbon fiber inside the injection molding. These reinforcing materials are usually used using more conventional manufacturing processes that are less productive. So it's very interesting, in order to introduce this technology to the automotive sector, it's very interesting to be able to do this mass production process of thermoforming and overmolding these big composite sheets, reinforced sheets. In EURECAT, we are able to work from the idea to the scale up, as I've shown to you in these two different examples. So we can discuss the company the needs, but also we can re-engineer the part and adapt the part to the process, but also have the installations and the knowledge to develop all the solution, to develop the tooling and to develop the process. So thank you very much. Here you have my my contact details. My name is Enric Fontdecaba, as I told you. This is my email, and I will be glad to hear from you and to answer any questions you could have about these two different technologies, heavy technology and a structural part. But also in our background, there's also issues about texturing surfaces and also using electronics inside plastic parts that can be of your help. Thank you very much and have a nice day.